In basic SIP, when one party dials another, the server, if it doesn't own the dialed domain, queries DNS and routes the invite down to the callee's server. There, the dialed address of record is resolved to the registered contact address and the request routed onto the phone. But that's basic SIP. In the real world, it's likely that features or applications will also be applied. Now, imagine an enterprise that polices international calling, not something typically in a basic server's skill set. So they'll probably have a SIP application server with an application that checks outgoing invites, perhaps rejecting those to international numbers. So when Dave calls Nath, on receiving the invite, the basic server knows to apply the feature and routes the request to the application server. The application then makes its check and, finding it acceptable, sends the request back to the proxy. A quick DNS lookup and the request is proxied downstream to set up the call. But now a question. How does the basic server divert the request from its regular path up to the feature server and back again? How does it force the request over this different route? It's a good question. Let's take a couple of minutes to find out. Actually, we've already learned a golden rule that provides the answer. Do you know what it is? Have a think and press play when you're ready. It's the route header rule. If a route header exists, then it takes routing priority over the request URI address. To force a request over a different route, a server simply adds one or more route headers. To force the request to the application server and back, the basic SIP server simply adds two route headers, the first being the address of the application server and the second being itself. Applying the rule, because a route header now exists, the server sends the request to the topmost route header, not to the request URI. Having checked the destination and deciding not to reject the call, the application server strips off the route header that brought it the request, and on finding a remaining route header, sends the request to the address in that route header, back to the location server. Now, knowing it's okay to proceed, a quick DNS lookup and the request is on its way. Note how the Calibre server stripped off the route header that brought it the request before adding another to force the request to elsewhere.com. Interesting. So if you were the Calibre server and you wanted to divert a request through these 5 additional servers and back to yourself, what would you do? Exactly. Simply add a route header for each of those servers, plus one for yourself. In summary then, if a route header exists, it takes routing priority over the request URI, meaning that servers can divert a request simply by adding a route header for each server. Each server en route strips out the route header that contains its address and proxies the request to the next topmost route header. Up until now, we've only seen route headers added by endpoint user agents when routing subsequent requests, but now we see them added real-time by servers as the request travels downstream, forcing the request to travel over a diverted route.